In this lesson, I'd like to solve another system of equations by using the addition method, also known as the elimination method. Remember, the goal here is to get the coefficients for one of the unknown variables to be opposites. So right now in current form, we have a 2 and a 4 for the coefficients for x, and a -1 and +3 as the coefficients for y. So we're going to have to do a little bit of work to get opposite coefficients. I'm going to multiply the top equation by -2, because by doing so, that will result with a coefficient of -4 in front of x, which would give me opposite coefficients. So let's rewrite this first equation after multiplying through by -2. So -2 times 2x gives me -4x. -2 times -y gives me +2y. And a -2 times +14 will give me -28. So we rewrote the first equation after multiplying by -2. The second equation stays as is, 4x plus 3y equals 8. Now we have opposite coefficients in front of the x variable. So when we add these two together, we have -4x plus 4x, that gives me 0. So we can just put an x through there. 2y plus 3y is 5y. And -28 plus +8 is -20. Then we divide both sides by 5. And I'm left with y equals -4. Okay, so we found that y equals -4. And of course, my answer is going to be an ordered pair, right? The solution to a system of linear equations is the ordered pair that satisfies both equations. So we know the y component. We need to find x now. So if I were to back substitute this y equals -4 into either y here or here, it doesn't matter which equation I use, that will give me my value for x. We're going to solve for x. So let's use the bottom equation. So I have 4x plus 3 times, not 3y, but 3 times -4. And that's going to equal 8. So we have 4x minus 12 equals 8. And we're going to add 12 to both sides. And I'm left with 4x equals 20. And you can see x equals 5, right? We divide by 4, divide by 4, x equals 5. So, the answer to my, or the solution to my system of equations is the ordered pair x equals 5, y equals -4. Now, of course, we can do the check. We can plug in 5 and -4 to both of these equations, and the equations left-hand side and right-hand side should be equal. I'm going to use this equation. I'm going to check with that equation first. So instead of 4x, I'm going to write 4 times 5 plus 3 times, instead of y, it's -4, and that all equals 8. Right, so I just took the second equation and I plugged in my x equals 5 for x, -4 for y, and then I'm going to solve to see if this does indeed check. Let me just draw a little dotted line here. So we have 4 times 5 is 20. 3 times -4 is -12 equals 8. 20 minus 12 is indeed 8. So we have 8 equals 8. It checks. I'd like you to try and plug in 5 and -4 into the first equation and see if that checks as well. If we did our work correctly, it should.